In the earliest light of the universe, there is something that shouldn't exist. A region, colder than everything around it. Not slightly colder, not by chance, but dramatically colder, stretching across billions of light years. Scientists call it the cold spot. And if the cold spot is real, then our understanding of the universe isn't? When astronomers first mapped the cosmic microwave background, the faint afterglow left behind by the Big Bang, they expected to see a nearly uniform temperature spread across the sky. Tiny fluctuations, yes, but nothing extreme. Then they found it, a massive, unusually cold region located in the direction of the constellation Eridanus. At first, it seemed like an error, a glitch in the data. But when NASA's Wilkinson Microwave Anisotropy probe detected it, and later the European Space Agency's Planck satellite confirmed it with even greater precision, it became clear. This was real. The cold spot spans roughly 1.8 billion light-years across. To put that into perspective, our entire galaxy is only about 100,000 light-years wide. This is not just a small anomaly, it is a cosmic scar. According to standard cosmology, the universe on large scales should be statistically uniform. Temperature variations should exist, but they should follow predictable patterns. The cold spot does not. It is too large, too cold, too unlikely. So what could cause something like this? One explanation is something called a supervoid, a vast region of space containing far fewer galaxies than normal. If light from the early universe passes through such an empty region, it loses energy. By the time it reaches us, it appears slightly cooler, and scientists have indeed found evidence of a large void in that direction, often referred to as the Eridanus supervoid. But there's a problem. Even a void that large may not be enough to explain the full temperature drop observed, which leaves a more unsettling possibility. What if this isn't just a void? What if it's a bruise left by something else? Some theories suggest that our universe may not be alone. In models of eternal inflation, new universes constantly form, expanding like bubbles in an infinite cosmic ocean. If two of these universes were to collide, the impact could leave behind a mark, a region where the structure of space itself was disturbed, a cold spot, a scar from another universe touching ours. There is no direct proof of this, but the idea remains scientifically discussed, and the cold spot fits the prediction. Of course, there is always a simpler explanation. It could all be a statistical anomaly, a rare fluctuation, an extremely unlikely, but still possible, random event in the fabric of the cosmos. But even that raises a question. Why here? Why this large? And why does it feel like more? Because when we look at the cold spot, we're not just looking at empty space. We're looking at a place where our understanding of the universe begins to break. A place where physics hesitates, where certainty fades, and where one quiet possibility begins to whisper. What if this is not just our universe? What if we are not alone in existence itself? What if our universe is only one of many? Not separated by distance, but layered beyond what we can perceive. And what we're seeing is not just a random imperfection, but a consequence. Because if two universes ever came into contact, even for a fraction of a second, the result wouldn't be obvious. It wouldn't tear the sky apart or leave behind something we could easily recognize. It would be subtle, almost invisible, a faint disturbance hidden in the oldest light in existence, a region where something doesn't quite belong. And the cold spot might be exactly that, not just a statistical anomaly, not just empty space, but a trace, a scar, left behind in the fabric of reality. Because when we observe the cosmic microwave background, we are not just looking into space, we are looking back in time, nearly 14 billion years, to a moment when the universe was still forming. Every tiny fluctuation, every variation in temperature is a record, a fingerprint of the early universe. And yet, this one stands out.